Welcome to the tutorials of DeepSense. My name is Lu Yan. I am the HPC platform specialist of DeepSense, Faculty of Computer Science, Dalhousie University. Today's topic is Introduction to HPC and the DeepSense systems. Here's the agenda of today's talk. First, I'm going to talk about what is high-performance computing. The short name is HPC. And I'm going to introduce the DeepSense HPC computing infrastructure, including its hardware and software. Third, I'm going to talk about the basic skills to use DeepSense HPC platform. Okay, so what is a high-performance computing, HPC? High-performance computing enables users to solve complex computationally demanding business, engineering, and scientific problems through computer modeling, simulation, and analysis. The applications used in HPC require high bandwidth, enhanced networking, and robust compute capabilities. So here you see a big picture. The picture shows a data center. Usually in the data center, you can see a lot of racks. In the racks, you can see a lot of machines, switches, tape libraries, and a lot of network cables connect them together. A data center could be small and could be huge. So what are the main components of an HPC? Some people say there are three main components. Some people say there are three characteristics of HPC. The first one, it must have huge compute power. The machines in an HPC environment are not the same as your desktop or laptop in your office or at your home. The machines in a data center or in an HPC environment must have big memories, very powerful computation capabilities. That means they have a lot of CPU cores and GPUs for example, for the AI model training. The second component is huge storage system. Nowadays, the data for different businesses and applications are getting bigger and bigger. For example, in the research areas or businesses in weather forecasting, mechanical engineering, biology, and the ocean industry, we have more and more data, and we have more value data and image data. They take space. So for AI models to train on those data, we must have a stable and a safe storage system. So storage system is very, very critical to an HPC environment. This is not something you can find on your laptop or your desktop. The third one is high-speed interconnect. If our interconnection between all the machines are very slow, of course, you cannot get high-performance computing. So in a HPC environment, people always use high-speed switches to connect the compute nodes, which is the compute hosts, and storage, and other like backup machines or whatever machines in the system using high-speed switches to get high-performance computing. There are other components about in the HPC environment. For example, stable parallel file systems, job scheduler like Slurm or LSF, operating systems like Linux, and applications for AI or general purpose computation or conductor of with Spark. So we're going to introduce other components in an HPC environment later. Here's an introduction of the DeepSense HPC computing infrastructure. This picture shows the racks of DeepSense HPC infrastructure. We have 5 racks. These machines These racks stay in the machine room in Mount Campbell building on Dalhousie campus in Halifax. What do we have in these racks? First, what compute power do we have? So we have detailed information about this video. You can find them on the public wiki of DeepSense. I give the link here. For the compute power, you can follow the link to see more details of it. We have three kinds of compute hosts. People also call compute hosts as compute nodes. First, the first category is a large memory. We have 20 large memory machines. Each has 512 gigabytes of memory, 20 core. They are IBM Power 8 machines. They don't have GPUs, so these 20 machines are CPU machines. The second category is huge memory machines. We have 4 of them. Each machine has 1 terabyte of memory. Each machine has 20 cores. Also, they are IBM Power 8 machines. They don't have GPU. The third category are GPU machines. We have 10 GPU machines, and each GPU machine has 2 GPU cards. The GPU module we are using are NVIDIA Tesla P100. Each GPU machine has 512 gigabyte of memory and also 20 core, CPU core. And they are IBM Power 8 NVL machines. For storage, you can also look at our public wiki to get more details and policies and how to use them, the best practices of storage, etc. So here we only give a brief introduction of the storage. For each user on our system, the user would have three directories. One is the home directory. The home directory is 1 terabyte. And the home directory is good for your personal scripts, your code, and your test data. The second directory for you is Scratch. It's 2 terabytes. It's a temporary space for your temporary output and your temporary data. So you need to regularly clean your Scratch space to make sure you have you don't take all the space of your Scratch space. Otherwise, your jobs may not be running normally because of the space problem. The third directory is data directory. You can put your research data, your raw data here, and you have 2 terabytes of data directory, your project group data, your raw data here for your AI model training. So 3 different directories, they are designed for different purposes. So if you need more spaces on DeepSense, you can talk to us, tell us your requirements, tell us why you have that requirement to enlarge your space on our systems. We will try our best to satisfy your requirements. We also have software on the system. We have some basic software and compilers and modules. For example, the C and C++ compilers, Python and R compilers. These are some general purpose or some compilers come with the installation of the operating system Linux. And we also have a lot of AI frameworks. These are the very important software on our system for our project development. We have Anaconda. Anaconda is an open source distribution of the Python and R programming language for scientific computing. It aims to simplify the package management and deployment. So we have Anaconda installed globally on our systems, and we also encourage our users to install Anaconda in their home directory for their own flexibilities, because different users may use different versions of Anaconda. So we provide help how to install Anaconda in their home directory, and from there, how to activate their own environments for their AI projects. And we also have a TensorFlow, PyTorch, and Caffe, and so on. These AI frameworks for AI model training. We also encourage we already built TensorFlow and PyTorch on our systems globally. Users can just need to run a single command line in their home directory to install TensorFlow and PyTorch. If a user needs other software or other AI frameworks, just let us know. We'll install them for you. A lot of users like to use Jupyter Notebook. On our cluster, you can use Jupyter Notebook. You can get the GUI interface, edit and execute your Python or R code from there, and let our compute host run your Jupyter Notebook jobs or workloads for you. We have applications for big data. We installed IBM WMLA. That WMLA represents Watson Machine Learning Accelerator. In WMLA, there is a very big component. It's Conductor with Spark. On Conductor with Spark, users can develop their big data projects. And Conductor with Spark is IBM's Spectrum Conductor. It's an enterprise-class multi-tenant platform for deploying and managing Apache Spark, Anaconda, Dask, and other application frameworks and services on a common shared cluster of resources. So we have, I just mentioned, you have your home directory, your data directory, and your Scratch directory, right? Those directories are shared on all the compute hosts on the cluster. So on every single machine, you can access your directories. So that's called shared directory. And the Conductor provides the ability to support multiple concurrent and different versions of these applications while dynamically allocating and sharing resources between tenants and applications. And also, IBM Spectrum Conductor provides enterprise security while enabling performance at scale and maximizes resource usage and sharing to consolidate resource silos that would otherwise be tied to separate application environments. So it's very flexible and it's very powerful to make use of all the compute machines under the Conductor cluster. And it has the flexibility to coordinate the compute hosts for your big data application. And it also make use of all the compute resources in the cluster and make use of all the available memories for your big data applications. So it's very powerful. It's a very powerful tool for big data project development. There are some basic skills that you need to you need to have to use the DeepSense HPC platform. The first one is Linux. You can see some basic Linux instruction on this link. It's the public wiki of DeepSense. If you have zero background of Linux, don't worry. We don't need a professional Linux person to use our systems, because in our instruction, we give very clear instruction how to log on our systems. And we also list the common and popular Linux commands for you that maybe in most cases, you only need less than 10 Linux commands for your jobs. So don't worry about Linux. There's another big thing, big component of HPC, using DeepSense HPC. When you run your jobs, you have to use our job scheduler, LSF, to submit your jobs. LSF is provided by IBM. it's a job scheduler to allow users to submit their jobs, monitor their jobs, queue their jobs, remove their jobs, and see the accounting data of their jobs, see the history of their jobs. So it's going to be very convenient for a user to see all the jobs he has run and how many jobs exit with error information, how many compute resources the jobs have been using. So it's a very important tool users have to learn. The same as Linux, most people do not have LSF background. We have very clear instruction, just several very important commands for you to learn, and then you can just start running your jobs. So no worries at all for zero background of LSF. The third one is shell scripting. You may or may not use to write scripts for your jobs. Basically, shell scripting is scripting language that will make your jobs convenient or make you your management of your jobs more convenient to interact with the Linux system. For example, you can set up the environment variables, you can set up the libraries, you can list a batch of commands to let them run one by one automatically. You can just put all this kind of stuff in your script. There are a lot of web pages teaching people how to write shell scripts. You can learn it by yourself, but of course you can always ask questions to DeepSense support. At the very beginning, you may not know how to do this, but this won't be preventing you from submitting jobs and looking at your jobs and use the compute power on DeepSense. Yeah, basically this is the introduction of the HPC and the DeepSense platform. So if you have any questions, feel free to contact support at deepsense.ca. And the tutorial here doesn't tell you all the details of the topics we cover in the video, but you can see a lot of detailed information on our public wiki. So please do not rely everything on the videos to learn. You need to rely on the public wiki because there are more detailed information, there are more topics for you to learn and go through. Anyway, thank you so much for listening. Feel free to send us your questions and comments. Thank you. Bye-bye.